So you just try to understand that we are having driver mode, executors, along with executors, we are having cache memory. And inside that, we are having one cluster manager who will take care about all the nodes which were available. And if the node is available or if the node is in dead condition, it can be known by cluster manager and it will give the information to the Spark driver. Spark driver will convert the number of, sorry, code into number of stages to tasks. Spark will convert, driver will convert code to job. Means code is nothing but like job is nothing but a piece of code. So that job is converted into number of number of stages to number of tasks. That's what we need to remember always. So this is a local mode where we are using only one node, that is our community edition. That is only the source and that is only the target. So means driver node and worker node would be in the same node. That is what? Same compute. That is nothing but local mode. Here, the best example for local mode is the community edition. And these are the Spark modes where we are having executors. And you see, these are the cluster modes. What we are having standalone, CAN, source. So who will take care about all the executors or no slave nodes? Cluster manager. And above the cluster manager, we are having driver. Driver will convert job to stages to tasks. A job is nothing but a piece of code which reads some input from HDFS or local system and data writes some output. Okay, this is nothing but piece of code is nothing but a job. Stages means job is divided into number of stages. Why we need to divide into number of stages? Because we need to send that code to worker nodes and we will make that worker nodes to work. So stages are classified as map and reduce. So map reduce stages. It is easier to understand if you have worked on Hadoop and want to correlate. So what we have already seen the map reduce technique. So if I'm saying stage is nothing but where we are using in one stage, one map, one reduce. Means one for loop and one aggregation. Stages are divided based on computational boundaries. All operators cannot be updated in a single stage. Why? Because we are having two kinds of transformations that we will see now. Not all transformations will complete in one stage. Okay, not all transformations will complete in one stage. It happens over many stages. So the work would happen on many stages. Like what you need to understand. I'll give you simple example. Suppose I'm having one route. Okay, I'm just taking an example. Okay, try to understand, that's it. So I just want to come to Suryapeta to Bangalore. Suryapeta to Bangalore. Or any other. Hyderabad to Bangalore. This is for Hyderabad and this is Bangalore. So I want to travel. To travel from Hyderabad to Bangalore, I'm having straight transport. Means I'm having a bus, train, flight, anything. It is available, right? So a no break journey is there. No breaks. Single journey. Like if I catch the bus, I can go by overnight. Or if I catch the flight, I can go in 2 hours, 1 hour. If I catch the train, that also will take overnight. So what is that? Hyderabad to Bangalore, I'm having direct access. So I can go by direct Bangalore, I can go. But if I took any other village, okay, if I took any other village, suppose I'm taking example of some Tenali, okay, I'm taking this is Tenali. From here to Bangalore, okay, from here to Bangalore, if I want to come there, what happened is there is no straight transport. What I need to do is I need to catch another bus or train here, okay, another bus or train here till Guntur or Vijayawada. These are main cities, Guntur or Vijayawada. Then I need to go from here to Bangalore. So what is happening? It is happening in two stages. First stage and second stage. So this is not the single process. We are taking two stages. We are catching one bus here and going to Guntur or Vijayawada. From Vijayawada to Bangalore, another bus. Or train also will send, but no flight. So it looks two-stage journey, right? I need to catch the bus here. I need to drop here again. I need to catch another bus and I need to go to the Bangalore. And in the same way, if you are going for Hyderabad to Bangalore, it is not like that. You are having one straight transport where you can go in single stage. This kind of, okay, now I'm just explaining about buses, but in your transformations, whatever you are doing, in the transformations also, this would be like this. So those who are having the multi-stage, okay, multi-stage transformations. Multi-stage transformations means what? Let me go here. This is what MapReduce, right? This is what MapReduce. So this is entirely one process, single stage. What is happening? It is taking input, mapping, and reducing and giving to the output. Meanwhile, what is happening? Shuffling is happening. Shuffling is nothing but what? Adjusting the nearby data to get the count, right? So here I'm having welcome to Hadoop. You are having all these things. Hadoop, how many times you got? Three times. Three times. Bad one time. Class one time. So what is happening? Here the complete data is going to, here the data is looks like this, right? It is very clear. Welcome to Hadoop class. Hadoop is good. Hadoop is bad. Okay. This is the information what we are having. What happened? This has to be split it into number of pieces, and that piece is assigned one key for that. What happened next? All the keys which are similar is collected at one place. Bad, class, good, Hadoop is to how many times it came. So what happened here? This data got shuffled over here. This is having no meaning, right? Shuffling is nothing but this. So this data now aggregated and gave how many times each word came. Okay, this many shufflings will happen if you are having multi-stage operations. Means you will have shuffling the input and shuffling the out. That's what multi-stage. Multi-stage is nothing but shuffling going to be taking place. Multi-stage is nothing but you will have shuffling. We will go in deep, but as of now you understand this. You will have shuffling. Okay. This is a multi-stage. Multi-stage means you are having shuffling. Number of stages are going to be increased. In single stage, in single stage transformations, you don't have any shuffling. No shuffling takes place. Only one stage. So multi-stage transformations are called as wide transformations. Wide transformations. So, multi-stage transformations, shuffling takes place. This kind of transformations are called as wide transformations. This is very important because even when you are working, so you need to be very cautious when you are using wide transformations and narrow transformations. This is, and single stage is called as narrow transformations. Why? Because wide transformations are costly. Wide transformations are costly transformations. Whereas narrow transformations are not that costly because no stages. So wide transformations are costly transformations, narrow transformations are not that costly. This is why if an operation or a work is done by narrow transformation, you need not to go for the wide transformations. Always prefer narrow transformations. Always prefer narrow transformations. If that work is not done by the narrow transformations, then only go for the wide transformations. Wide transformations, what we are having? We are having multi-stage, or you can say it as more shuffling is happening at the input and output. But narrow transformations, there is no shuffling, it is single stage. I'll give you the examples. Okay. And one more thing you need to understand. In Spark operations, there are two, two operations. One is transformations, another one is actions. These two things you need to remember. First thing is Spark is having two kinds of transformations. This transformations. First one is wide transformation. Second one is narrow transformation. Wide transformation is multi-stage operation where more shuffling is happening. Narrow transformation is nothing but a single stage operation. There is no shuffling. And again, Spark operations are divided into two. One is transformations and second one is actions. Transformation is nothing but where you are applying some change or something on data. But action is nothing but you just taking the output, means like print. You are having print statement in C language, right? Print. So wherever you are having print statement, print, count, collect, all these kinds of transformations or actions. Okay, all these kinds of operations we can call, those are actions. Action is nothing but just printing the data after applying the transformation. So we are having two operations. One is transformation and second one is action. So we are how many types of data sets we are having? RDD, data frame, data set. RDD is nothing but resilient distributed data set. Okay. RDD is nothing but resilient distributed data set. So distribute collection of JVM objects. So RDD is specially used for the text files or log files. RDD cannot be used for any unstructured or semi-structured or structured data. We are having only text files and log files in RDD. Now we are not using RDD. We are using data frame. Data frame is, it is able to operate all kinds of data, which is structured, unstructured, semi-structured data. That is data frame. Even data set also can work on that accordingly. But the problem is data set is only used by Java and Scala. Now we are learning Python, PySpark. So we are into data frame, but we need to learn the RDD because RDD is the backend for the data frame, and you will have all the interview questions on RDD. If you understand properly RDD, then it can be easy for you to understand data frame. Okay. So what is the RDD features? Distributed collection, which is immutable. Immutable is nothing but once you define an RDD, you are not going to change that RDD. So once you define the RDD, it is not going to change at any cost. So that is what you need to understand. RDD is immutable and which is fault tolerant. How it is fault tolerant? We can see that fault tolerant is nothing but even if you got any error or any something, some node got failed, then also your data is available. That is nothing but fault tolerant. And these are lazy evaluations. RDD is having lazy evaluations. What is lazy evaluation? We can see in this session. Okay. Functional transformations means we are having transformations and actions in the RDD also. Okay. Data processing formats, structured as well as unstructured data. This is wrong, but we are following RDD is only for text files and log files. Whether it is structured or unstructured, it doesn't matter for us. It should have only log files in that. Programming language supports Java, Scala, Python, R. So we will come back to the data frame again. But as of now, we can understand what is RDD. Have you tried with community edition? No. RDD. RDD definition is resilient, distributed data set. RDD is nothing but resilient distributed data set. So what is nothing but resilient? Resilient is nothing but RDDs can recover. RDDs can recover from node failures. From node failures. Because They store information about the transformations that created them, allowing for reconstruction of lost data. Simply you remember that RDD means resilient distributed data set. Resilient is nothing but it can recover from the failure. As simple as that. So if I am saying resilient means it can recover from a failure, means it never lost the data. That is what RDD. Okay. Distributed. Distributed is nothing but we already know that. Distributed is nothing but we have discussed this, right? Distributed is nothing but data within an RDD is partitioned. Okay. So the data is going to be partitioned and it has splitted across the nodes. That is what distributed. Resilient is nothing but it is recovering from the disaster. And next one, distributed is nothing but data within an RDD is partitioned and distributed across multiple nodes. What are the nodes? Worker nodes across multiple nodes in a cluster, enabling parallel computation. So here we are having Spark driver. What is happening whenever I have created the RDD, we will see that how many number of partitions it is going. Okay. So whenever I have created any RDD, what it will do is, first of all, this cluster manager, it will take that RDD and it will split into number of pieces and each piece is given to each node. Okay. So what happened? These nodes are taking the partitioned data from the RDD and they were started computing parallelly. How many nodes you are having? That many computations it will take. And you need to remember in our community edition, we are having only one worker node, one driver node. That is local mode. We have discussed it, right? So even that the RDD is partitioned, it will only one node will execute all the partitions. But in general, when you are using Spark, on the top of Spark, if you are using RDD means you are splitting the data into multiple nodes and that nodes will work parallelly. Parallel is nothing but all nodes will work at one time. Okay, and this is nothing but RDD. This is distributed. And next, data set. What is data set? Data set. Data set is nothing but RDDs hold a collection of data which can be any type of object. Means what? I'm giving the example. Java objects, Python objects, etc. RDD is resilient distributed data set. Resilient is nothing but we are ready to recover, which means If the node failure occurs, then only you are able to retrieve your data. So allowing for reconstruction of lost data. Distributed is nothing but your RDD is distributing into number of partitions. Each partition can be given to each node. So all the nodes will start working at the same time, which is nothing but parallel computation. And data set holds a collection of data inside it. So data set meaning is nothing but it holds an information inside it. Even data frame is also a data set. Data set in like we are having data set, right? That also a data set. Three are data sets only. Data set is nothing but which is having collection of data. This is nothing but RDD. Okay, this is nothing but RDD. So let's understand what is the practical session. Okay. So for this, actually, we need to get one more thing, one more clarity. We are having, before I have explained the same for the SQL, now I'm explaining again. You see this, suppose I'm having database. And SQL client. We have already seen this, okay, SQL client. Here we are writing the language, right, queries and all. So if I have written some code here, what will happen first? Why? What happened to you? You people are not talking at all. Don't you remember this? Okay. Okay. Whatever it is. I'm just, this SQL client, what it will do? It will generate one session. That is for what? That is for
Authentication.
authentication. Very good. You are all serious on me or what? Because you waited, right? That's why. Okay.
No,
Huh? No? Then why you are so numb? You are not, you people are not talking at all with me. If you don't like, tell me before only. I'll stop that session. Okay. Session will be established. Session will be established. This session will be established for what? It will give you the authentication. Authentication. Why I am telling this? There is a reason behind this. Okay, authentication. Whenever SQL client want to communicate with the database, what happened? Here one authentication will be given. That means SQL session has been established here. After this, what will happen? There would be SQL context. SQL context. What it will do? It will convert the code into white code. We discussed it already. This is not a new one. So optimizer. This also can be called as optimizer. What this optimizer will do? It will convert the code into white code, which is nothing but encoding. Encoding is nothing but what? The human, like whatever we are having programming languages, understand by human, that is converted into machine language, which is understand by the system. As simple as that. So we are having two things, SQL session, SQL context. Hope you guys understand this concept, right? If not, let me know.
yeah,
Yeah, right. Why I'm telling this, you will understand now. So I'm having Spark and Python. this Python code we are writing in the UI, right? User interface. You are writing in the board. So wherever, suppose if I'm writing here, I just want to write Python code here. If I want to write here, what is going on? This code has to be communicated with whom? Backside Spark engine is there, right? With the Spark engine, this code has to be communicated, right? So this Python code, what it will do, it will ask for a Spark session. There would be a Spark session. The same way how we are having in the SQL client, the same way we are having Spark session. Whatever, this drawing is not that clear, but okay, you just understand. So we are having, what is here? Spark session. Why for SQL session we are having? My God.
SQL context.
Yeah. SQL session. What is the purpose of this one?
Authentication.
Authentication. Spark session is also for authentication only. Okay. And after this, we are having Spark context. Spark context, what it is doing? SQL context, what it is doing? It is doing converting the
Convert
code.
the code.
Same. Here also the same. For this guy, I have explained this much. For the Spark context. Because so in Databricks, one more thing you need to understand. This is very important. Even in interviews also, they will ask you. Spark in Databricks. Okay, in Databricks. Spark is applied on many like many areas you are having Spark. Okay, we are learning Databricks. You try to understand the difference. Spark, that particular application is so many so many applications we are using that HDFS system along with Spark and different platforms they were using. But here where we are discussing, keep in mind that we are discussing in Databricks. Okay, in Databricks, no need to create Spark session. Okay. So they have given one variable. So no need to create or authenticate or do something. They have Databricks people, they have given a variable that is nothing but Spark. If I'm writing Spark means anywhere, if I'm writing Spark means Spark session. If I'm writing Spark, it means it is a Spark session. Which is so if I want to write the Spark, then Spark session, simply it is Spark. Anywhere if you are saying Spark means that is Spark session. Okay, Spark context is SC. SC. If you are saying SC, it means Spark context. If you say SC, it is Spark context. Spark session is represented by Spark. Spark context is represented by SC. Okay. You understand, right? So here I try to print this. Okay, this one is fine. So Spark session is nothing but Spark and Spark context is nothing but SC. Now we need to understand in how many ways we are creating. Yesterday we discussed that. Okay. In how many ways we are creating RDD? How many ways? RDD creation. Okay, how to create RDD and how many ways we are having. Okay, how to create RDD. This is a syntax. Okay, I'm just giving any variable here. RDD name equals to SC. What is SC now? We just discussed now.
Spark.
Spark
For
context.
context.
Yes, Spark context SC dot. And we already discussed what is this. RDD is distributed. How it is distributed? Parallelly. So I need to write SC dot parallelize. This is a syntax. Parallelize. I need to give the collection. This is a syntax for the creation of RDD. And how many ways we can create? This is giving the collection. This is one method. Second method is again the same. RDD name equals to SC dot Spark context dot text file. Inside that I need to give the path. So we can create RDD in two ways. We can create RDD in two ways. One is SC dot parallelize method. One is SC dot text file method. In the text file method, we are giving the path. In SC dot parallelized method, we are giving the collection directly. Okay. Collection is nothing but what? Collection is nothing but any Python collection. Suppose example is list. You are having list in the Python. Okay. That can be the collection. Okay. And what is path? Path is nothing but if you are feeling this is slow, you can tell me. I can increase the pace of my teaching. Okay. So path is nothing but data file with location. This is what. And two more things I need to clarify here because we are going into the coding. Function is nothing but function. If I'm saying function is nothing but any function which is any Python function. Okay. Simple, I can say that. Function is nothing but any Python function. Method, if I'm saying method, so which is inside class or package, which is nothing but inside class or package. So there would be functions and methods. If I'm calling that as function, that means it is a Python function. Okay. Method, if I'm saying method, it would be package or class inside it would be there. This much, if you remember, that is it. Okay. There is help in the Databricks. Let's check what is exactly SC. SC is nothing but Spark context. I'm just trying to ask help. SC. This is a Spark context. I'm trying to ask Databricks what is help, what is SC. So SC is nothing but which is a version where we are using Spark context. So data descriptors inherited from PySpark.context.Spark context. SC is nothing but Spark context. Okay. So these are the packages. jar, zip, egg, All these packages can allow the Spark context. And I want to ask, what is sc dot parallelize? It is giving all the example, you can see. Parallelize in module PySpark context. Class or collections, which is iterable, can be given as parameters. Returns, you can see, this is what I'm explaining. Returns, RDD. Returns, RDD. So RDD represents distributed collection. Distributed collection. RDD represents distributed collection. So what it is returning, that is very important. What you are creating, what that returning. You are creating RDD, it was returning RDD again. So you are creating the RDD, it was returning the RDD again. So it means what, even if you create data frame, it will return RDD only. So what it is returning, that is very important. So it is returning the RDD. Okay. So examples would be like this. It is given by the Spark. Okay, let's try to create one RDD. You know Python, right? I'm just giving range function list. I'm taking one variable list number equals to range, which is a range function. So in that I'm giving how much range 10. If you are giving Python range 10 means it will print you the output 0 to 9. Okay. In Python, if you are taking any number, the index starts at 0. Let's try to print this. See, list number, it is how much, what is the range? Range 0 to 10 means 0, how many numbers it will give? 0 to 9. 10 is the outer range, 0 is the, so it is starting from 0. Okay, if I'm saying index in Python starts from 0. That you need to remember always. Okay.
Mhm.
Right. Now I'm just trying to create. So this is for commenting. Hash is for commenting. But if you are using your SQL editor in here, then for you the commenting is, this is Python notebook. That's why commenting is hash. In SQL, you're having SQL editor in your Databricks. There you need to give 2 hyphens. That's what you need to remember. I'm giving hash to comment this. Just trying to create one RDD now. I'm just taking RDD underscore numbers is my RDD name, which is equals to how to create that sc dot parallelize. So inside this, I'm calling the range. I can call any collection. I can call any collection. Suppose if I want to execute this entire cell, I can use run cell, but I want to execute only this part, then I can select that part and execute. I have selected this, I'm executing this. So RDD is created. RDD is created. Have you seen anywhere? This is created, but have you seen anywhere? It's created or something? No. So until and unless an action has been triggered on the top of the data frames or any top of the transformations, then only you are able to start execution in the Spark. or even in the Python. That is nothing but lazy evaluations. Lazy evaluations. Lazy evaluation is nothing but, suppose if you are having a train, right? For that, all the compartments are connected to that. All the compartments are in the ideal stage, right? So they were there. When the train is going to move, so train is going to move when the engine starts. Am I right? So when the engine starts, all the compartments started moving. In the same way, if you are saying Python or Spark transformations, until and unless an action has been triggered on the top of any transformation, nothing is happening at Spark side. It will keep everything in the ideal state. Okay. So it will get ready. All the compartments get ready, means all the transformations get ready. Suppose if I gave it here anything, so to print that, I need to give the action. What is nothing but action? We will see that. And I'm just creating another RDD here, RDD underscore num equals to sc dot parallelize. And one more thing, I don't know, you people are started your community editions or your Databricks environment. You started it.
Yes.
Anybody is trying this? No? Parallelly, work with me. Let's check, because
Not at the moment, no.
because this particular thing is not available in your paid version. So if it is actual Databricks, you are not able to work with RDDs. Only community edition allows you to work with RDDs, because RDDs has already expired. That's why I'm asking you. You try it once from your end, it is working or not. So RDD underscore number equals to, I'm giving the sc dot parallelize. Inside that, I'm giving a list of Python. Just executing this now. I have created RDD underscore num. So now let's try to collect this. Okay. How to collect this? So to print this, I need to, how to display the RDD? Just how to display RDD. So to display RDD, you need to use actions. Actions are nothing but in SQL, we have already seen, right? DRL and DQL. Actions are nothing but DRL and DQL. What is DRL is having? Select a statement. This is for SQL. But in Python, what are the actions? Let's see now. So DRL display. You're right. Here for the RDD, it is not for the, for data frame, you can use display, but for RDD, you need to use select. This is a function. This is a function. So how to give that? I'm giving the example. RDD dot collect. Here, what I'm telling is, I have created two RDDs, but not able to see anything, because these are all lazy evaluations. Until and unless an action has been triggered on the top of any transformation, you are not able to perform anything in Spark. That is called lazy evaluation. So now I'm giving collect here. Collect. See, now you are seeing the job executed, right? Once I gave the collect, I have seen the job executed. Here I have not given anything. You are not seeing any execution. So no execution is happening. No execution is happening until and unless an action triggered on the top of data frame, RDD or anything. So dot collect I have given. This is happened. Okay. So again, I'm just using for this also. RDD underscore num. Okay, this is RDD giving the select. See, it is printing the output. 1, 2, 3, 4, 5. Again, I want to collect RDD underscore numbers dot collect. See, it is not printing because I'm taking 2 in 1 step. I need to run this. List has no object. Yeah, right. So here you can see that I'm giving range 10 and I'm giving the list number here. This list number here. I'm trying to collect it, but it is not printing that. Okay, it is not printing that. You can see that because list numbers are type. If for collecting, it is not printing that. You can see. I just want to know what is the type of that type of anything. If you want to know the type of RDD underscore numbers, I'm just trying to execute this. This is list. To get the type of anything, you need to give in between type of. Because in SQL, you need to give the type of the variable or a type of whatever you are using variables, right? For that, you need to give the data type. But here in Python or PySpark, it will automatically take the data type. If you type 1, 2, 3, 4, it will automatically take it as integers. Suppose if you are giving letters, it will take as string. So it is automatically taking the data type. That's why we need to here. Did I mention anything about RDD? What is the type of RDD or something? No. Any data type I have given for this? No. It is automatically taking that. Now I have defined some numbers for RDD underscore number. Just check that what it is giving. RDD is always a collection, right? I'm just entering type of. See, it is giving PySpark.RDD. So it is giving the data type as RDD. For this RDD, it is giving as list. Okay. Do you know Python list? Or I need to explain?
No,
Uh,
man.
Shall I explain that? James?
yes. Yes, please. I have an idea for it, but not as yeah,
No.
please explain. Yeah.
But in Python code, we are having list. List is nothing but used to store collection. Used to store a collection. Okay, suppose I'm having like this, so not that big. Okay, I'm having like this. Another 5 more minutes, please. Be patient. So you need to understand this is a collection. Okay, this complete thing is going to be a collection. So collection here, this is a collection, and I'm having data here. Data. And this is index. Okay, Python list is nothing but you are giving some data. Suppose I'm giving Johnny or John here. Okay, I don't know how many blocks I have drawn. If I have given the name as Johnny. Okay, for this Johnny name, what is my index? Starting index would be always 0. So
0.
J is assigning for 0. O is assigning for 1. H is assigning for 2. N is assigning for 3. Again, N is for 4. So this 5-letter word is going to take, sorry, 6-letter word is going to take how many numbers? Totally 5. 0 to 5. 0, 1, 2, 3, 4, 5. So this indexing is taking from 0 and it is ending at 5. Actually, so it can store, list can store how many types of, minimum basic, right? Integer, string, float, Boolean functions, you know that? Or I need to give that?
Yes.
Yes, yes.
No,
Right.
no, I know that. Yeah.
So it can store, list can store all types of data. Like integer, string, float, Boolean. Like this. What is this? Then I'll give you the example. Suppose I'm defining a list. It would be like this. Names. You can give names as list. Age. For names, how to so if I'll go through the communication, then it would be easy. I'm able to create a list. So if I'm giving age equals to I'm taking, anyway it is in Python only, so it will work. Age equals to, even if you want to try Python, you can try on Jupyter notebooks also. In Databricks, Python coding is somewhat little bit different because this is core Python where you are trying to get everything. If you are perfectly want to get that, you can try in Jupyter notebooks. But even Databricks will also support this. Okay. So age equals to, I'm just giving 25, 18, 21. Suppose if I'm asking to print the age, it is giving the list 25, 18, 21 like that. And suppose I'm taking multi is just a name. Here in this, I'm giving age 11. Okay. And maybe I need to give it in the, just wait a second, this screen share is disturbing. For this, if you are giving any string, what you need to remember is, always remember that you need to give either in double quotes or in single quotes. You should give that. If you are not giving any quotes, it won't take, it will throw the error. I'm just giving double quotes here. Okay. If you are giving in between double quotes or single quotes, it is taking as string 11. And I'm taking apple. You can see that I'm using the combinations. I'm using the combinations. You try to understand this.
Mhm.
I'm not giving 25, 18 like that numbers or anything. I'm just giving one float, one boolean. True is a boolean. If you write T small letter, definitely it is going to take as string. T and F should be always capital letters. See, it is in black. So it won't recognize as boolean function. So true,
The boolean,
T
okay.
should be always capital letter in Python. F also should be always capital letter. I'm just trying to execute this. Let's check whether it will execute or not. It is executed. Now I want to get what is the type of this one. I have defined nowhere. This is a list or something, but it has to give us list. List. What it means, list can accept all kinds of data inside it.
Okay.
It can
Okay.
accept all kinds of data types. So if you are giving string, it is taking. If you are giving integer, it is taking. If you give the float, it is taking. If you give the binary, it is a boolean function, it is taking. So list can accept all kinds of data types. And one more thing you need to understand under list is used to store the collection. And suppose if I want to, I have given age, right? I just want to give one more item to this. Okay, little bit late, don't worry, but this is very important. I'm using append function. I'm using append function. Age, I have already defined over there, age dot append sorting. Does it printing anything? No, these are
No.
all transformations. It never prints anything. Now, try to print age. You need to give the action on this. Even Python is also lazy evaluated. You just try to understand. If I give any transformation, it is not going to print. If you don't say to print, it never prints. So that is what the lazy evaluation. And one more thing, back end also it doesn't work. It will keep in line everything. It piled up all the all the transformations, but it never executes at backend. Even if you give any mistake, any wrong here, it won't recognize because no action is there. It is not working at all. We think like all connected, all processed inside, but nothing will process until and unless an action has been triggered on the top of the transformation. That also we will see, but I'm just giving print age. What we are expecting? We are having 25, 18, 21. Right? We are adding 40 for that. So in the list, we need to get 40 also. Why we got 42 times? I already appended and again executed 2 times. That's why I got 40. Let me execute this again. 40. Be cautious while you are working with programming. So you are getting. And now I don't want all this 40 set back and I want to pop it. Okay. So just I'm using age dot pop function. So pop function, what I want to do, I want to delete 0 and it won't display, right? So what I need to do, I need to give print. I'm giving here only. Let me try whether it will work or not. Print it got popped out 25. It is not deleting. It is giving you the 25. I'm just trying to print again age. You see, you will have all that. Print age 25. So this 25 got removed. The 25 got removed due to this indexing. That is why indexing is very important in Python. So if I thought 25 is the first one. If I gave 1, which is going to be delete? 18.
18.
And did we able to retrieve it back? No. Once deleted,
No.
deleted. So you be cautious when you are giving your indexes. Suppose I gave 5 here. 40. Out of index. 0, 1. So why? Because this is the new set, right? It is already 25 is deleted. 0, 1, 2, 3, 4, 5 only. 6 I have given. It is saying index out of range. What is deleted? Now let's try to get. This is our new data set. Okay, you can. So range function. Range function. 2 minutes. If you want, I can close this, or I'll give you the range function also in this.
1.
Okay. So I want to discuss range function with you. 2 minutes. You wait, please. So range function. I'm giving range values equals to range 20. So what is our index? 0, right? From 0, it will print to 19. I'm giving range values as range 20. I'm writing one for loop for this. For I in, for loop, how you will write? You will take for I is nothing but it will iterate through the, here 20, right? So it will iterate through 20. Let's check here. I'm giving range values. Print I. Invalid syntax. For I in range values, right? Only range values. So inside the for loop, I need to give. For any function, even I always forgot this. You need to give colon here. So if you didn't give colon, it will throw the exception. And you need to, if you are writing for loop, while loop, any loop, this has to be inside the loop. Otherwise, you will get indentation error. Means it is not inside the loop. So for loop, I have written, I have given range function 20. So how many numbers it has to print till 19? 0 to 19. If I gave the
19.
same for 100, it is giving 0 to 99.
19.
0 to 99. This is what the for loop. So minimum value would be 0 and maximum value would be minimum value for range function. Minimum value is 0 and maximum value is n minus 1. What is the maximum value you have given? That minus 1. This must be remembered. And remaining things we will see in the next class. Okay? Any doubts till now?
Not right now.
Thank you.